So in the last lesson we learnt that it's not only fuels that react with oxygen in the form of combustion reactions, but also metals. And in this lesson we'll see that non-metals also react with oxygen. So let's take, for example, sulfur. Okay, we've got, remember this is called a burning spoon. Its posh name is the deflagration spoon, but that's a bit of a mouthful, so we'll just call it a burning spoon. There's my sulfur. It's a yellow powder. Okay, and you can watch this again in the practical demo section. And what we do is we take our sulfur and we hold it above the flame for a bit, and after a while the sulfur melts and then starts to react with oxygen in the air around it. It starts burning, and it burns with this light blue flame. Okay, this really ought to be done in fume cupboard, because the fumes or the gas that's produced here is sulfur dioxide, which is quite a unpleasant gas. Okay, so what we're going to do now is we're going to take the burning spoon and the burning sulfur and we're going to place it in a gas bottle, alright, like that, and we do this in the video, and the sulfur starts to burn away. So while the sulfur is reacting with oxygen, as I just said, an unpleasant gas is produced called sulfur dioxide. So we have sulfur, let's write out the word equation. Sulfur plus oxygen gives us sulfur dioxide. Okay, we can write out again the symbol equation for that. Sulfur is S, and then again oxygen, remember, is O2. So this is a simple equation really. Sulfur plus oxygen gives us sulfur dioxide, which is SO2. Remember that the di in this terminology means two. So you can have monoxide is one oxygen, dioxide is two oxygens, trioxide is three oxygens. In this case it's two. Right, and then we write the up arrow, which tells us that we've produced a gas. Now this gas will gradually fill the gas jar, and at the bottom of the gas jar we've got an indicator solution. We've got sulfur that's burning, and sulfur dioxide is filling up the gas jar. And what will happen is it's quite a heavy gas, so it will gradually move downwards and dissolve in the indicator solution, and what you see is that there's a colour change, quite a dramatic colour change. I shake the gas jar around so that it absorbs all that gas, and very quickly the indicator solution changes to this colour. It's a pinky red colour, so it's not a strong acid, but it's certainly a medium to strong acid produced. So what happens is that the sulfur dioxide in the gas jar dissolves in water to produce an acid called sulfurous acid. You will have also heard of sulfuric acid. Sulfuric acid is much stronger than sulfurous acid, but sulfurous acid is also pretty nasty. And so we can also write out the symbol equation for this. This is fairly straightforward. We have sulfur dioxide plus H2O for water, which gives us H2SO3, as opposed to H2SO4 for sulfuric acid. Now, this is also the acid found in acid rain, which you'll have heard of, where sulfur present in coal is burnt in power stations to produce huge amounts of sulfur dioxide, which then gets absorbed into rainwater in the atmosphere and then falls down to the earth as sulfurous acid or acid rain. Right, then what is important here then, as we learnt with the metals, well, that the metals react with oxygen to produce a metal oxide, and we learnt that metal oxide is in general alkaline. Well, with non-metals, they react with oxygen to produce non-metal oxides, and these are acidic. Right, so you get the same thing. If you take carbon and burn that in oxygen, you get carbon dioxide. You dissolve the carbon dioxide in water, that will be acidic. Not as strong as the sulfurous acid, but it will be acidic. Alright, so non-metal oxides react with water to form acidic solutions or acids. Yeah. So just summarise that looking at the periodic table. You remember that we can divide the periodic table into non-metals and metals, and we can do that if we take boron and carbon. All right, we draw a line between those two and then go down the stairs going this way. All right, that way, then down a step. All right, so we have the non-metals to the right of that division line and the metals to the left. So in a general rule, we can say that if we take a metal such as sodium or calcium or magnesium or copper, etc., and we burn that metal in oxygen, we will get a metal oxide, and then dissolve that metal oxide in water, then that will form an alkaline solution. We say that metal oxides are alkaline. Likewise, if we take a non-metal such as carbon, phosphorus, sulfur or chlorine gas, and we react those elements with oxygen to form non-metal oxides, then the non-metal oxides will be acidic. So we can say non-metal oxides